All right, so number 11, we have a system that is joined by a semi-permeable connection. Let's say it's filled with something like agarose. And we want to know what is going to happen in terms of whether water or solute will move. First thing is that only the solvent will move, not solute. And so in chamber A, I have 0.2 molal of ions. And in chamber B, I have 0.32 molal of ions. And so in the absence of any added osmotic pressure, we're going to move from chamber B to chamber A, and that is going to be credited response B. We look at number 12. Solubility of a solid solute in water typically increases with increasing temperature because the dissolution is, well, if the dissolution is endothermic, so if we have solid plus heat, that gives us dissolved solid. Of course, this would be solid, this would be aqueous. This is an endothermic reaction, so increasing the concentration of heat favors the formation of more dissolved solids. So it needs to be endothermic. So we can eliminate A and B, and higher temperatures favor dissolution. The best answer is going to be C. 13, what is the freezing point of a solution produced by dissolving 22 grams of a solute in 400 grams of benzene? There was some data missing from this problem, so let's first deal with that. When it comes to number, I guess that's number 13. When it comes to number 13, we need to know that the Kf of benzene is 5.12 degrees Celsius per molal, and the normal freezing point is 5.48 degrees Celsius. And so remember that the change in the freezing point is equal to I, which in this case will be 1 because we're talking about molecules, M times Kf. We have 22 grams. The molar mass of that molecule is 306 grams, and it is in 0.4 kilograms. And we're going to multiply this by 5.12. So this will tell us how much the freezing temperature is going to be lowered. And it's going to be lowered by 0.92 degrees Celsius. So we'll simply subtract that from 5.48. And we will get an answer of 4.53 degrees Celsius. So for number 13, the credited response, the best answer is going to be C. I did round off a little bit. I got 4.53 even after I rounded off. So the best answer is going to be C. 13, the credited response is C. All right, number 14, we're asked a conceptual question. Why does the reaction rate decrease when the temperature decreases? Of course, temperature does not affect the energy of activation. The only thing that can really affect the energy of activation is the presence or absence of a catalyst. the reaction rate is proportional to this rate constant. So if this is going to decrease, then the rate constant must decrease, which makes B the best answer. So temperature exerts its effect by changing the mathematical value of the rate constant. Number 15. If we have a reaction that's neither endothermic nor exothermic, this means that the activation energy must be absolutely the same in both directions. I think a simple graph will illustrate this point. Energy of activation of the reverse reaction, energy of activation of the forward reaction. There is no difference. So they will be absolutely the same. That is going to be answer choice B. So the credited response for 15 is answer choice B. Okay, so we are told in question 16 that the delta G for a given redox reaction is positive. This means it's not spontaneous. So K's got to be less than 1. We can get rid of A. We can get rid of C. It also means that the electrical potential must be negative, which means we can also get rid of B. The best answer for 16 will be answer choice D. We can look at our equations for just a moment to illustrate this. We know that delta G is equal to minus NFE. So when this is positive and I divide a positive by a negative, I get a negative. So E is negative. Also, when delta G is positive, remember it's going to be E to the minus delta G over RT. That's equal to K. This means it must be less than 1 because I'm taking the negative exponent of base E. So for those reasons, the best answer for 16 is response D. So moving on to number 17, we want to find out which chemical process is reduction. In A, bromine's going from -1 to 0. That is oxidation. In B, you're going from fewer oxygen atoms bonded to chlorine to more. That is also oxidation. In C, you're going from more oxygen atoms bonded to manganese to less. That is chemical reduction. Also, iodine, you're going from 0 oxygens to 1. That is also going to be oxidation. So the best answer choice will be answer choice C for number 17. Number 18, we want to calculate the molarity of dissolving 15 grams in 475 grams of water. Remember, the density of water is 1 gram per mil. So we want moles of solute in liters of solution. So 475 grams is 475 mils, which is 0.475 liters. And the molar mass of NaOH is 40. So putting these both together, 15 divided by 40 divided by 0.475 gives us an answer of 0.789 molar. And that is answer choice B for number 18. Number 19. We're trying to look at the relationship between the boiling points of NaI and calcium phosphate. So NaI would be 0.4, and I believe I changed the value in this from 0.08 to 0.081. There's more solute particles in the calcium phosphate. The boiling point of calcium phosphate will be higher, so we can get rid of A and B. And the best answer will be D. It's lower because it has fewer dissolved particles in solution as compared to calcium phosphate. So number 19, the credited answer will be D. Have a Le Chatelier's principal question for number 20. So we want to find out which of the following changes will lead to more fake blood. Fake blood is going to be a product. So if I add a cation to SCN, that's going to tie up the SCN and it will shift the equilibrium to reactants. So that would lead to less fake blood. So let's look at B. I'm going to add ferric nitrate and the intensity goes down. Actually, the opposite would occur. I'm going to add SCN and it says the fake blood decreases. That's not correct. I add silver plus with SCN, which is going to decrease its concentration. That would also shift the equilibrium to the left. So number 20 is one we need to look at because none of those answers actually, just looking at the question stem, lead to more fake blood. So we would need to increase SCN or we would need to increase Fe3+. So adding ferric nitrate would work, but the wording in the answer choice is wrong. So I'm probably going to go back and give everyone credit for number 20. All right, that gets us through the first 20. I'm going to pause for here and then I'll pick up with number 21.